What I'd like to do for today is begin with the quiz. Let's talk about the quiz from last week. This week, we're supposed to focus on sampling distribution of a statistic, which is the second part of Module 8. But we can go back. If anyone has questions, we can go back. We can solve problems, whatever you like. Because in the binomial section, all I did was ask you to identify a binomial. So also the quiz today, I can put a question or a problem on binomial. So we can take an hour for or 45 minutes for binomial, maybe. I think it's easy. Luis, Joel keeps saying it's the easiest one so far. Um, but some of you may not have gotten over the bridge or the hurdle to see that it's easy. So we can maybe review our problems there and then talk about the sampling distribution of the statistic. And then next week is going to begin inference, right? You're starting inference this week. You should be studying inference, the last module 9. And inference is the last topic, but it's big. If you print the notes, you're going to see it's a big set of notes, but that is because lots of exercises, lots and lots and lots of exercises there, all right? So that's going to help as well. If you notice, well, in the quizzes or the tests, I'm calling them quizzes online because that's the name of the utility that it's called quiz. I can't change the name, so I'm calling them quizzes, but they're tests really, right? Every week. The tests that I'm giving you, I'm trying to, I'm testing the material, keeping you relevant, providing you feedback, um, and preparing you for the final exam. I have some final exam questions there in the multiple choice. What I'm thinking is because um, there are 8 topics, really. Really, there's eight topics. I have put it in 9 modules because the first one's an intro, but anyway, it's like 8 topics. And I'm thinking to just give you for the final exam like 8 questions, right? And you have to pick up, you have to pick a time slot on the days that I said. It's not going to be June 16, but June 17, 18, I can add the 19. And I'll put the details on the platform so you guys can review it. So it's going to be June 17, 18 or 19. So some time slot in there. And I'll list the time slots because I have to be available too. So, and then those 3 hours, I will observe you. It will involve you analyzing data and responding. I trust that if you do all the exercises and you understand for the most part what you're doing, you should be able to complete those exercises. I will be there for you, if you have questions. We can go offline or we can, talk on the phone or we can go to the chat, the private chat. So you're not on your own, but prepare yourself, have some outlines on paper, have the formulas on paper, have some examples for yourself. The advantage here is you get to prepare everything, your documentation. The disadvantage is it's a lot of documentation, so you have to get organized, right? So it's use the time. You have a month, less than a month. Let me count the weeks. 3 weeks. 1, 2, 3 weeks. A little less than 3 weeks to prepare for that test, okay? You're going to have all your materials available to you. Like I told you, I don't want you using any kind of AI. It's hard to say that now because AI is linked into everything, even if you do a Google search. But directly taking a problem and putting into an AI browser, I will be able to tell that you're using that, and it's prohibited. Okay, so you gotta work the problem out and show me, demonstrate you've worked out the problem. You can upload if you started teaching yourself how to use Excel with the in the lessons I show you how to use Excel to solve problems. That's fine. You're going to have to upload the Excel document with any formulas or um, anything that you put in Excel. I don't want it PDF. I want the Excel. So I'm going to ask for Excel. If you typed it out, I prefer you to handwrite and Excel. I'm not going to let you type it your answers. I mean, I'm letting you guys do it with the tests, but for the final exam, I'm going to want you to write by hand. Um, anyway, I'll write out those details and I'll put them on the platform so you can review them and you can ask me next week and the following week. So 17, 18, and 19, you're going to pick a time slot in there, and hopefully I don't have to meet too many times, but I can put everyone together in those time slots in maybe 3, 4, 5 groups of you. It's not too many of you, so we should be able to work it out. Okay, it's going to have eight problems, one from each of the topics. Maybe I'll combine 8 or less. All right, so you can spread out your time that way. All right. Any questions for me? So we have, I can also meet with you virtual if anybody wants to go over anything. Um, let me see.
So, Professor, you're not in the office anymore, like for next week, for example?
Oh, you want to see me in person?
No, I mean, like, just in case, since we are very close to each other. So,
Yeah, no, I'm going away on Friday. Well, I'm gonna be around
no, I
till
mean, because
Thursday.
I'm also going away on Wednesday already, but
Okay, so if you want to see me,
okay.
Monday, Tuesday, or yeah, you're not gonna hear Wednesday. I leave on Thursday.
All right,
I
cool.
leave on Thursday. So if anybody wants to see me in person, if they prefer to be in person, even though it's a distance class, I'm here. But we can meet virtual as well and solve any problems virtual as well in a mutually convenient time. Let me just check something here. Okay, let me go to the materials. Give me a minute. Are things um are you making progress? Maybe you're not up to date, but the past material, do you feel like you made progress and you have an understanding of the past material? That's what I'm hoping for, that you're all caught up before, with the last weeks. And we can talk about this week. What about the past material? Do you have any questions about for me?
Not questions, but I think I was able to get the last quiz, the makeup quiz. I'm waiting for
Good.
the grade
Yeah,
just to
yeah.
make sure,
I
but
will.
I think I got it. I
Good,
think so.
good, good.
So
Yes, I'm glad that, let me see, there's one message. I'm glad to hear that. I'm just looking here.
Professor, and next Saturday, I do have also a business trip. So next Saturday I won't be able to join, but I'll watch the
Yeah, I'll put
recording
the
there.
recording. I
Hmm.
didn't put the recording from last week yet, but I will also put that up. I'm sorry, I'm also behind. I have I don't know, I guess I have excuses, but I don't really have excuses. I should be able to catch up. I It was my birthday and everybody wanted to take me for dinner. That was what threw me off. I have to be honest. That's
But
what
that's a
happened.
good problem to
No,
have
but
to
it's
have like a
Exactly.
crazy. It's
free
like,
I was
why
about
do I
to
food.
have
say,
so
like,
many
is that
friends
a
all of a
problem? I
sudden?
mean, I wish.
Hey,
Everybody,
Professor, my birthday was like 10 days ago or on the 19th. Nobody offered to take me out. So you have a good problem. So
Yeah.
I went to 5
Hey, happy
brunch and
birthday. Oh my
dinners.
God.
Happy late birthday to
Happy
both
Oh,
of
birthday.
thank
you.
you,
to,
thank you.
to
I try
thank
to
you.
lay low. I try to lay low because it's such a busy time. And then that's what happened. That is my excuse, not excuse, but my reason. Every chance I got to catch up or down low, lay low, catch up on my grading, it was taken. And then what are you going to say? No? When people offer you, it's like
No,
how
no,
many times
no.
it's
That's a gift. You have to
I
take it.
know. I know people are so wonderful.
Free food. Come on. Of course.
Yeah, and that's the other part. I don't want to eat so much, but I don't want to be rude. I'm trying to stay in shape now. Like I'm just trying to be more active. And the next time I'm gonna say, let's go to the beach. Let's just walk around. Let's put our feet in the water. I'm just checking something. Sorry, while I'm talking to you. Yeah, when I went to Florida, I was invited to speak in Florida, and in Florida it was very interesting. I was in Gainesville, and I was meeting with professors individually to talk about research, and we never sat down. Everybody said, let's go for a walk. Let's see the campus. Oh, it's raining. It's okay. They just walked in the rain. I mean, it was never pouring. And I thought, wow, that's what we need. Like, that's the culture that I accept. I really appreciate. I'd never seen it anywhere like that, like what I saw there. I think they were really happy because it wasn't so hot. They wanted to be outside, and I happened to be there because they tell me that it gets really hot in the summer there in Gainesville.
Professor, I'm in Georgia, a little north of Atlanta, and this morning it was 60 degrees. So this is I'm wearing a sweater. This is very unusual temperature for this year, like 60s, and we're almost in June. I'll take it, but yeah, it's chilly today.
Yeah, so yeah, it's yeah, you want to either take advantage or things change, right? It's like, and I popped in over there. Actually, one time I was in Miami and it snowed. So yeah, weather weather can be strange, and it's hard to prepare for when you're traveling. Okay, so I'm going to get to let me do the quiz first, and then we're going to go to we can talk about 7. All right, let's see. All right. It's so funny that students, so for the first one, can you see? A factory
Yes.
tests 100 light bulbs, and each is classified as either working or defective. And I ask you to indicate if it's binomial or not. What did you say?
I said it was.
Okay, so you guys
Me too.
put it in the chat so I can see total. Put in the
Okay.
chat if it's say yes or no. Just binomial, yes? Not binomial, no. Let me just tally what's people said. So okay. Very good. All right, so now we have to prove why it's binomial. So I want you to tell me, and I gave you the idea, and Luis Joel also mentioned, N, identify N, and P is what is going to help you here. And what is N? N should be a number, and it should be known. And P should be the probability, and it should be known. So yeah, put it in the chat what N and P are for this problem. So scenario 1, you all said it's binomial, but if you cannot identify an N and a P and they are known, you do not have you do not have enough information to say it's binomial. It could be binomial, but if you don't have the information on N and P, it's not binomial. So you guys are telling me N is 100 because that's spelled out clearly, and it's 100 tries that we're looking to see if, well, we actually don't know what we're looking for here, do we? You guys made a lot of assumptions. Notice what, now you realizing where I'm going with this one? What is your assumption that you made that you shouldn't have made?
That there were only 2 possible outcomes was
Well,
the
there's 2,
assumption?
but we have to be clear. What are we looking for?
Oh, they're
So
working like bulls.
But you
y-
assume it doesn't say that.
yeah, what I did was that if I'm not mistaken in this one, what I wrote was that it could be binomial, but we don't have like what is the success identified, so
Exactly. It
we
needs
can
to be clear. Okay, so also I kind of made an assumption that you understood that. It's not clear here, okay? It's not clear. Are we looking for working or defective? Your assumption is, yeah, well, I'm going to see if it's working. It doesn't say that. It's classified as either working or defective. I didn't translate it. I just imagined that you would cut and paste it to translate, but okay. Next time well, today I'll make sure it's translated.
Professor, I
So,
have a quick question on this one.
uh,
And I guess it will
well, let me
follow.
finish. Let me
Okay.
finish, Ida. So it's not saying what the success is. You need to, okay, so what I outlined for you, for everyone who watched the videos, if you didn't watch yet, what I outline is find X and P, and then to answer the problem, you need to know K. Okay, X. X is the possible outcomes. Before you know possible outcomes, you need to define the success. What is a success here? It's not clear. Am I looking for working or defective? You assume it's looking for working, but it's not clear. Because I can't define the success, I haven't had the success defined. I don't know what P is going to be. You all assumed it was 50. Where does it say it's 50 there? If you're going to run a manufacturing plant and 50% is the probability of working, that's a pretty bad production line that you're running. Okay. You hope it's going to be 0.01% defective, right, on your production line. But you all thought it was 50%. So it's very interesting. So know your bias, right? You guys just threw some numbers in there. Your bias to just invent. You invented something. It's not there. It's not there. Okay, so you guys got that one wrong, but I can give you half points for that one. Because it should be binomial, but you don't have enough information. I'll now read what you had to say too. All right, any questions about that one? And you all did it, by the way. You all did it. So what does that mean? It's a weakness. It's a blind spot, right? That you guys are inventing here. Okay, so let's read the next one. A student guesses on a 10-question true-false quiz, and we count how many they get right. Okay, so what's the success here? Let's go in order. What's the success? What are we looking for?
The ones that they get right.
So getting it right, the correct response. Very good. So that's success. So what can X be? What will X be? Here, I'll put it in the chat so you guys can see it. So success, so this is how you're going to answer the questions. Equals correct guess. Okay, and then the question I just asked is X. So what's X? What can X be? X is equal to the number of correct guesses out of 10. That's what X is. So X can be, and numerically, that's the definition of X, but numerically, X can be, tell me what is X can be. What are the possible outcomes for X? Numerically, what are the possible outcomes for X?
0, 1, 2, 3, 4,
Aha.
5, 6
An
until
item
10.
is started with 0. Always remember the 0 because no successes is possible. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's X. And then I taught you how to identify K is the particular question you're looking for. There's no particular question here. We're just looking at the outline. Success, X, and now you have to do N and P. So what's N? Oh, that one we know, right? How many times will we look for the success? 10 times. And what is P? Aha. So here it's not spelled out, but what is the key word here? What is the key word in the sentence? Palabra clave.
Is it true or false?
No.
Guesses?
Guesses. Guessing. When you're guessing, it should be, and there's no, if it's basically a fair, equal chance of getting the right answer. And if there's, the answer is either true or false, there's only two possible answers. So they have to have, so this is the thinking. There are two possible answers, true or false. Each one is equally likely if you're guessing. So that's the like the part that's not spelled out here, but that's what you need to know. Okay. So each one is equally likely. And so what do the probabilities have to sum to?
100 or 1?
Right. So if they're equally likely and the probabilities have to sum to 1, and there's only 2 of them. I mean, I'm really spelling this out for you because I want you to be able to use it in any case. So the probability of it being is 1 and 2, or 1/2, 0.5. Okay, so there are two possible answers, true or false. Each one is equally likely. The probabilities should sum to 1. So the probability of a correct answer is 1/2, and the probability of the wrong answer is 1/2. And why am I doing it like this? Because what if you have 6 multiple choice questions? What would P be? And that's
So it would be like, sorry, you said 6 multiple options
if there's 6 multiple choice questions.
for all of the 10 questions?
Yeah, if each one had 6 multiple choice questions rather than true false,
Then
what's the chance?
1/6.
Yeah, so that the same logic. They're all equally likely. They all have to sum to 1, so it's the fair split of all of them. So 1/6 each. In this case, 1/2 each. If there are 5 questions and 1/5 each, there's 4 questions. That's the logic. Okay, so we write that down. So this one is binomial, and we know N and P, so it is, those are the answers. So scenario 2 is binomial, N is 10, and I could put P is 0.5 because of that keyword, guess. They're guessing. The chance of getting it right is equal for any of them. So that's why. So now you're going to be able to do scenario 3 very easily. Put it in the chat, yes or no, and then N and P. So put it in the chat for scenario 3. So you have to put it, if it's no, you still have to tell me what's wrong with N or what's wrong. You have to explain, okay, if N is there or not there, if P is there or not there. I'm going to look for that. Okay, dice rolled 12 times. Okay, you have to tell me yes or no first, and then what N and P are. If you say no, then you have to tell me what's wrong, N or P. So what's wrong? N is missing or P is missing? Or is success not well defined? Right. Okay, you guys are getting the hang of this. Please tell me yes. So we're going to roll 12 times. So N is 12, but what am I looking for? If I'm just recording the result, is that binomial?
No.
No. The action of a binomial is you're looking for something, the success. You're looking for something in particular. Well, we're just writing it down, but in a binomial, you're supposed to look for something. And if it's not there, you say it failed, right? So success or failure. And here, what's going on? So there are not two possible outcomes every time we look. How many possible outcomes are there?
6.
6 possible outcomes, right?
Is that only because we don't have the success defined? If we say
We
that,
don't have the success defined.
okay,
Remember, scenario 2 we did. Is it right or wrong? Okay.
So in this case, let's say that the problem says that how many times it shows a 5 in the dice.
Exactly. That's what's
Then
missing.
that, okay.
Exactly. Because then if we're just writing down what's there, that's not a binomial. We're supposed to look for something, a particular number or not. So if we combine them, like you said, if we combine 1, 2, 3, 4, 5, 6 on the dice into 5 or not 5, aha, now we have options. Okay, so there, another tricky one. So I said, yeah, 1 point for binomial or not. So it could be a binomial, but the way it's stated, it's not. Okay, so it's not a binomial. So far now, the only one that's binomial is 2. All right. All right, so the answer here is, I'll put it down here. No. And success, so some of you said this, is not defined. So N equals 12, but P is not clear. No, it's just is undefined. I don't know, that's not the word. Is no, I don't know if it's not even known. It's just the success is not defined. So P is not defined. I mean, it's not known because it's not defined. So P is the problem. But that's because success is the problem. So always think success, the possible X's, N, and P. And then if there's a question here about the probability, you look for the K. The K is the particular X's that you're going to try and calculate. All right. Number 4, a survey asks 100 people to rate a product on a scale of 1 to 5. How about that one? Answer the questions. Is it binomial? And then tell me why or why not by going through N and P. Success, N and P. You guys got a hang of it now, right? So it's not because there's 5 options, not just true or false or 5 or not 5. Mm-hmm. Okay. And what about anybody else going to write down? It's clear. You're writing it down somewhere. So the problem in 4 is it's not 2 outcomes of success and failure. The success is not defined. Mm-hmm. Good. Okay, we want to try 5. If you still don't get this, you want to ask me later, just feel free to ask me. Okay, so the problem with 5 is we don't know how many times we're flipping. So this is a different kind of a problem. It's not a binomial. So you are going to become experts in the binomial. And then I mentioned some other kinds of distributions just so that you know that what's not binomial, right? So be able to identify a binomial or what's not a binomial. And then anyway, you'll be more prepared, like, because now so I explained to you n and p are the parameters, because once you know n and p, if you identify this defined as binomial and you identify the parameters n and p, then you can make predictions, and that's the important thing. And it's similar for other kinds of distributions, and there are several kinds of distributions that are created that describe phenomena. Okay, so like the normal distribution had relevance in practice, and then they developed Gaussian statistics based on the normal distribution. So it's really important to know the normal distribution, but there's so many kinds of distributions that are created for making predictions. And the binomial is an important one for sampling theory. Okay, so good. So scenario 5 is not, because the n is not known. There's also the difference between understanding when you're solving these problems, and let's do a couple of problems. Understanding the difference between each time, which you need to know the probability of seeing success, and the total of all the times. That's solving a binomial problem. Okay, one is focused on each time, but you know that probability. That's the p, each time. But the total of all the times is what a binomial is helping you calculate. All right, so let's see some problems. Where do you guys want me to go for problems? Or you're going to let me choose? So understanding that there are the different documents, right? So we have the homework document, and then the tareas, and then the quizzes. This is the full set of solutions from the homework, which it's not enough to have the solutions. You need to understand, to do it yourself. Are there any of these problems you want me to do? Or are you guys good? If you guys are okay with it, I can just go on to the sampling distribution.
maybe in page number 2 from, I think it's tareas. I don't know. I have it printed.
The tareas, number 2.
It's like bin 1, bin 2, bin 3.
Which one? Tarea 1?
Um, I'm not sure. I should have this printed. I don't know. It says it's this one. I started it, but yeah.
Not this one.
Sorry, the one I was talking in mute. That one is the one that it's called bin and SDS homework. So it will be after tarea down. Go
Here.
down.
Oh, this
Uh,
document here. Okay, this
Yep,
one?
that one.
Oh,
Yep.
okay,
Yeah.
the one I opened. All right, and which one? Because there are some that are challenging, but I'll clear up any confusion. Which one?
Bin 10 and 12 maybe. 10 and 11.
All right. Okay, let me leave it for everyone to try it. Let's take a pause. I'll pause the video. Remind me to put it back on. And I'll give you 5 minutes to prepare. Okay, I'm back. Are you ready for 11? Or, yeah, 11? Do 11 first. Okay, I'm just going to write off. We're going to read together and I'm going to write it on my iPad and then I'll share my results anyway. The probability that a certain machine will produce a defective item is 1/4. If a random sample of 6 items is taken from the output of this machine, what is the probability that there will be 5 or more defectives? Okay, first, is this a binomial situation?
Yes.
Okay, so if it's a binomial, then you should be able to find me what a success is. Define success. X and P, and then because it's a problem about the whole sample, K. So what is success? What are we looking for?
5 or more defective samples.
No, that's not the answer. You're telling me the whole exercise. I just want to know each time I look, what am I looking for? Success.
A defective item.
Yes. So defective. So you have to be careful. Which one am I talking about? Defective. Each time I look. How many times do I look?
6.
Does everybody agree? 6? Okay, 6.
6.
And each time I look, so that's N is 6. Success is defective. And P is the probability of success. What is it? It's the probability of defective.
1/4.
What does it tell us? It tells us, right?
1/4.
It gives it 1/4.
Mhm.
Okay.
Yeah.
1/4. And it gives a fraction, and that intimidates some people. You can put it in decimals, but then it's going to be hard to find your answer there. You have to divide all of them. So let's do it with fractions, and then I'll show you how to do it with decimals. Okay, so we're going to say it's 1/4. And so let's fill in. So I'm going to go to my iPad now and share what I wrote down. All right, so I wrote down success is defective. I need to put X. What's X? It's by words, it's the number of successes in total out of 6.
So it could be 0, 1, 2, up to until 6.
Right. So I'm going to move this aside. This is in words, but I'm going to put, so that's what a success is. And I'm going to put numbers here. So say it again, Iram. So we begin 0, because no
0 up
success.
until 6.
1, 2, 3, 4, 5, 6. And now Joel Luis is going to tell me what K is.
Since it's from 0 to 6, right? We need to do the notation like P times X equal,
Not the formula yet. Just what is
or
K? What is K? So the last sentence or the last expression says, what is the probability there will be 5 or more? That's what I'm asking you for. So what we have to do is 5 or more. Is K is 5 or 6? That's
5
what I
or
was
6.
trying to get
Like,
from.
yeah. 5 or
So
6.
K is 5 and 6. Now the formula.
5 and 6.
So K, 5, and 6. So what I have to do is I have to use the probability formula for binomial formula
3
for
times
X equals K.
X. Okay, yeah.
But K is two things. So it's going to have to add together because they're mutually exclusive. I'm going to add X equals 5 plus X
Plus.
equals 6. And now we use the formula. Okay, so write all that down. Let me give you some more time to get the answer if you were on the wrong track. And then I'll do it. I can also write this as probability X greater than or equal to 5. That's even more than I expect from you, right? I just want you to get the answer, but this is what I'm going to solve to get the answer.
But then we sum both results, right?
That's what that is, yeah.
All right. And
So,
then we use only 4 digits at the calculator.
right in the end, yeah, to sum them. So I have a different rounding rule to use 4 decimals for probability unit or module. So this is because it says 5 or more of the total, and that's when you look over here. Here. No, I'm gonna do the whole thing with the calculator and everything. We can do 10 as well, but then I'll do another one. I'll do a few of these. You ready for me? So there's different ways to do this. You could look up a table. We could go into, we could go online and find the table with the binomials for this variable binomial n equals 6 and p equals 1/4 or 0.25. We could find it and just find the values on the table and sum them. But I'm going to want you for the test to show your work. So we have to do this step by step to write it down. And to do that, first, we begin with writing down the binomial coefficient, which is the probability, the amount of ways, so the number of ways out of 6 to choose 5 successes. That's what we write first. And then the probability of a success, which is 1/4, and the number of successes, and then the probability of a failure, because there's only 2 possibilities, 1/4 is the success, but then 3/4 is the failures. And then the total of the exponents here have to sum to 6, because we have to, this is the number, so I'll write it down here. This one is number successes you're looking for, and this number is the number of failures, and the number of failures plus the number of successes should sum to n. Okay, so that's the way that works. And these two need to sum, this one plus this one have to sum to 1. So we use all the possible, this one is the probability of success, that's the probability of failure, and this one means the number of ways of seeing um, 5 successes out of 6. So that's all the combinations, all the ways to see 5 successes out of 6. So if I have 6 tries, 5 successes could look like this, and then 1 failure. And so just cycling through the F, how many times can I do that? Right, you can move it through, and there's going to be 6 ways to see that. It's just going to be 6 because that's going to be F there, and then oops. It's just a matter of moving. So that's 6. So I explained to you, oops. Right? I explained to you that you don't have to write it every time now, right? Now we have a way of finding that. And somebody asked me last class, what is factorial? That helps you get that value. But I also teach you in the conference how to, or in the videos of the class, how you can get this out of your calculator. You can list them manually, but we're going to avoid that. The factorial concept and probability helps you get that manually, but it's also programmed in your calculator. So putting all this into your calculator, are you ready for it? We could simplify. So I could, okay, I'll do it on my calculator from left to right first because I want to see this, right? Oops. I want to see this written down by you. Not all this notation, but just this part. And then let's write it also for the second one. So now this one is, notice there's no, this is just a number on top of the other number. There's no line or anything like that. So this is the number of ways of seeing 6 successes out of 6. So you put the success with 6 successes and the failure probability with 0. Again, these have to add to 1. You could just copy the formula, but that's going to waste time and you might make a mistake if you're just copying. Try and understand what you're doing. This formula arises from the fact that each time we observe, it's independent. It doesn't change the probability of the success each time. That's why we can just multiply straight across. And this, using the exponent, it's just like 1/4 times 1/4 times 1/4 times 1/4, 6 times. But that captures it as well. So I'm going to put these in my calculator, but then I'm going to show you how to simplify these. So here's my calculator. And then, oops.
Yeah, sorry, Professor, because there's when I'm confused because after the probability of success in one of your videos, then you put like a parenthesis for the probability of failure, and then you close it, and then you put the la potencia.
You're gonna have to show me what you're referring to. Are you saying I made a mistake, or you're
Oh, no,
saying
no, no. I mean, like I'm confused because I mean, like in the calculator, we can punch, like the factorial, like second key, then NCR, and then you continue until the probability of success.
yeah, this is the binomial coefficient here,
Yeah.
and you can multiply it straight across. So I'm going to show you this one here first, right?
Okay.
So it's going to be, so this, another way of expressing this is, yeah, NCR, which we find over here, but it's in the exponent. So to get that, I have to hit first n, which is 6, second function, NCR, 5, and that's 6. So that's capturing the list that I made here, that there's 6, there's 6 ways. It's basically giving me this answer. There's 6 ways to see 5 successes in 6 trials. So that's what it's doing. It's giving me the 6 as a number. And then I'm going to multiply this amount. So if I want to put this in my calculator, so this is easy, right? Because it's 0.25 and this one's 0.75. But if you want to keep it as a fraction, how do we deal with the power here? Do you know? Let's open this more. Let's see. I'm going to clean this up a bit. All right, so if I want to keep this So this is 6. This one is going to be 1 over 4 to the 5. And this is going to be 3 to the 4. Do you know how to simplify that? That's how we distribute the power, right? So what is this on the bottom then?
4,096. Plus 4
This
to
is
the
going to
5,
be
6 to the 6.
4 to the 6. So this is going to be 3 on the top. So I'm just showing you how you get the answer there. I can do this in my calculator as well and just get the answers, but I'll just show you how to get it with the fractions. So it's going to be 18 over 4 to the 6. What is 4 to the 6?
4,096.
Is everybody okay with that? Now I'm going to add it to this one. And then I'm just going to do it completely from left to right with the calculator. And you would have to calculate all of the options and pick the right one. This is out of control. So this one, what's 6 choose 6? How many ways are there to see 6 successes in 6 tries?
So we cancel, right? Because it's 0.
Not
1.
0.
It's 1.
It's 1, sorry.
Yeah, right? Yeah, you got to be careful with the difference between 0 and 1.
No, I know.
That one's going to be 1. This one's going to be, anyway, so this is going to be 1. This is going to be 1 to the power of 6 is 1, and 4 to the power of 6 is like that. And this one over here becomes 1. So we leave it out. So we're going to take that down to be 1 over 4096. So this is 1 over 4096. So the answer is 19 over 4096. Any questions about that? So the answer is E. Now you didn't have to do it like that. I don't expect you to show me the fraction, just show me your logic. So let's start again up here and put all of this on our calculator without thinking too much. I prefer to think and simplify, but let's just not even do that. Let's put it all in our calculator. Let's put all this. All right. So, there's many ways to do this. You find your style. How are you going to find that? Doing the problems, practicing, finding what you like to do. So I'm going to want to see on the exam, I want to see this at least. All this, you don't have to do all the rest. This. I want to see that you can express the binomial formula. And then however you solve it is up to you. If you're going to put that, if you're going to get the from the tables, or you're going to put it in your calculator. So let me get the calculator out again. There's so many options. I have to think about all of that. So we're going to put in here from left to right, making sure your calculator is in AOS mode, meaning a honors order of operations, or PEMDAS. So we're going to do again 6, second function, NCR 5. You can just continue, multiply. You can put 0.25, y to the x, 5, multiply. So the calculator knows that you want to continue. And you can put 0.75, because 3/4 is 75%. And that's the answer. So you could store in 1, or you can write it down. And 4 decimal places, like Jose Luis pointed out. So we're going to put 0.004 4 down. And then the next one, the next one really does simplify. It's like painful to even type it in. So I'm just going to put that's 1 and that's 1. So all I have to do is 0.25 to the power 6. I can just add 0.25 to the power 6, and that's my final answer. Sorry, 4, 6. Now I didn't round anything. Let me get it 0.25 to the power 6. So this is, yeah. Put it in red. This is 0.0002, which gives me the final answer there. Okay, so what you could do is, for all the options, just divide them and you could compare the decimal result. In some of the older videos, I'm using the other calculator and I can actually keep the fractions in the calculator. There's probably a way to do that here that I don't know. I don't see it. The ABC option. Okay, so any questions? Everyone has a method to find the answer?
So yeah, because my question is, when you presenting the problem like in fractions, and then you turn it into decimals, to calculate it with the formula. In the videos, I mean, like, my question is how to calculate it. If I stay with fractions, or should I turn to decimals? And I'm talking about P, for example.
Well, I'm just showing you how you can get the result,
Yeah.
but you don't have to do that. That's what I said. That's what I'm saying. I'm showing you how to get it if you want to stay with the fractions, but you don't have to. So what you're going to have to do is take everyone there and divide it to see what the fraction is. So 1 over 4096, what is that?
Yeah.
Right? So this is 0.0002, and B, 3 over 4096. So you got to multiply that by 3. To look for your answer.
No, I mean, I got that, but like 1 over 4, of course, we know that is point 25, right?
Uh-huh.
But then to punch it on the calculator, I mean, like, we could also do it with the fraction, and we get the same answer.
You can do 1 divided by 4. You need to keep all the decimal places, because if it's 1 divided by 3, oops, it's repeating decimal. So you have to work with the storage keys and keeping all the decimal places. Or use Excel,
Yeah.
and that will help you store all the decimal places.
Yeah.
So you got to find your method. You don't have to know all the methods. You just have to find your method that you like, that works consistently for you. Unfortunately, you have a lot of options. I mean, it should be a good thing, but sometimes it confuses people. So to do fractions, you can also do 4 and invert it like that, or 3 invert it. That just flips it for you. You don't have to do the dividing. Okay. So when you see fraction, like I said, you guys, I know students freak out about the fractions. Just all I need to see is that you can express this in the fraction. Don't put decimals there, because if you round it, you might get the wrong answer. You got to use the fraction here. You got to enter the fraction into your calculator or into Excel or wherever, because if you round this, like I said, if it's 1/3, 1/3 is 0.3 repeating. It's not 0.33. So don't start rounding early. You're gonna maybe make a mistake. It's a bad habit. So keep the fraction until the end. Then see here I rounded and it doesn't affect anything, but don't round in here. All right, so have I said way too much here? Is that enough? Is that okay? The other thing you could do also is like I mentioned is find a let's see if I can. You can do it in Excel. Let's do it in Excel. That's probably the easiest. Because even when you look for a table online, you have to specify that you do not want the cumulative table because you want to get each piece of the distribution. Oh, I don't know why my Excel takes forever to open up. Makes me mad. Something to do with using the software at the university. I think I'm going to buy my own, get my own license. Why is it taking 100 years? I like to do 12 too. We're going to do 10 and 12. What in the world? So if you saw the videos I showed you, I believe I showed you how to solve these problems in Excel. So if you want to find the solutions to the binomial, you have all these options. If I put bin or binomial, and which one do I want to use?
Binom dist?
Yeah, just the binomial distribution, and it asks me for the number that I'm interested in. That's the K part. So I want to get 5. And I want to get 6, but I have to do it step by step. I can't do both together on one command. The trials total are 6, and the probability is 0.25. If it's something like 1/3, I don't know, can you put 1/3 here? Let's see if this works. 1/4. And then cumulative, I don't want cumulative. I don't want it to give me everything up to 5. I want it to just be 5 by itself. So I say no cumulative.
0, okay.
Oh, it worked. Okay, so it worked. Okay, so this worked. So I put the fraction in here, you see? And that's useful if you have something like 1 divided by 6 or 1 divided by 33 or something. Okay, so that works nice. So I'm going to put the formula there for you to see it. You can also use references. You can refer to a cell. Any of those can be a cell. And then I want to do it also for 6, and I want to add them together. If you need help working with Excel, let me know. And that's the same answer, 0.0046. Okay, that's our final answer. Okay, so recapping, what do we have to do? We have to find X, N, P, and K. K can be one value or it can be many of them that you sum together. Don't forget the 0 here, or you're going to get the wrong answer because it'll add up X equals 0, X equals 1, X equals 2, X equals 3, X equals 4, and X equals 5, and you don't want that. Okay, so let's go to 10 and then to 12.
Professor, is there a chance that we could also review STS? Because I know it's already
That's what we're doing now.
10:21.
That's
Oh,
what we're
okay.
doing now. Yeah, that's what the next two problems are. They're mixed together in that document. All right, so let's leave you guys to collect your questions for me. Let's do 10 and 12. What do you think? Okay, so I'll give you some time to do those. I'll pause the video.